Alright, now that you've made your guess, the density of an object is how lightly or tightly packed the object is. Its units are mass over unit volume, otherwise known as grams over centimeter cubed. So the heavier the object is, the greater the density is. For example, a bowling ball will have a greater density than a ping pong ball. Now to forces in motion. A force is a push or pull upon an object resulting from the object's interaction with another object.
Look at this dude. No.
A body at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon by an external force. In this example, the airplane has no external force acting on it, allowing it to stay still. For the second law of motion, the force acting on an object is equal to the mass of that object times its acceleration, F equals ma. As you can tell, when the airplane got pushed twice, it went slow the first time and fast the second time. The faster airplane therefore had a greater acceleration. Since the mass was the same, we can use the second law of motion, F equals ma, to tell that there was greater force that pushed on the airplane when it went faster. Last but not least, here's the final Newton's law of motion. For every action, there's an equal and opposite reaction. As you can tell, when plane 1 exerted a force onto plane 2 also exerted that same force onto plane 1. Momentum describes how strong a moving thing is. Things that aren't moving have no momentum. Moving things have less momentum if they are light or moving slowly, and more momentum if they are heavy or moving fast. Now for this procedure, what you want to do is stand in place and start spinning around with the same speed. Now what you want to do is alternate between arms in and arms out. Make sure to record what is actually easier and what makes you spin faster. If you did the experiment, you should have noticed that it was easier to go faster when your arms were in. Why is this? A special kind of momentum is angular momentum. This is when the object spins around and around like a top instead of going straight. The law of conservation of momentum tells us you can't just lose momentum, it has to go somewhere. So if a thing gets smaller, like an ice skater changing her center of mass, then it tends to spin fast so that it has the same total momentum. Now, what is a magnet? A magnet has two poles, one north and one south. The north pole of one magnet attracts the south pole, while the south pole of one magnet attracts the north pole. When both of the same poles are put together, they repel each other. Why did the iron filings create that specific shape around the magnets? This is because of a magnetic field. A magnetic field is when a magnet creates an invisible area of magnetism. The north pole of a magnet points roughly towards the Earth's North Pole, and the south pole of a magnet points roughly towards the Earth's South Pole.